And so as Andrew said, what I was going to talk today about was the challenge that, well, the multifaceted challenge of really trying to do sustainability in cities and in city planning. And this is something that I've been working on for 6 or so years now, and something that I'm not going to jump off and spend my entire career doing. And so today I want to talk specifically or motivate this through the story of one particular city, and that's the Sino-Singapore Tianjin Eco-City. So this is an artist's rendering, an architect's rendering of this brand new eco-city. It's about an hour outside of Beijing. It was designed by some of the leading architects, engineers, designers, and notably architects, engineers, and designers from China and Singapore. And I'll explain in a moment why that's really important and really relevant. And it was planned for construction starting in about 2010, going through 2009, going through about 2019. So it's still under construction. It doesn't look like this today, which is why I'm still showing you this. Now, this idea of an eco-city was something that's pretty new. It actually came about around 2006. The first one was further south in China. It's this project here called Dongtan, which was planned outside of Shanghai on an island that's in the middle of a river, kind of where it outlets into the ocean. And this was a brand new, meant to be a brand new greenfield development, so nothing existed here before. And it was meant to be entirely carbon neutral, powered by renewable energy, and basically process all of its own waste and water on site. It sought for these really, really intensely challenging sustainability targets. And it was no surprise to anybody that 2 years later, nobody was even talking about building this anymore. There are a whole lot of reasons why that I'm not going to talk about today. We can afterwards if you're interested. But it really set the standard for these eco-city projects aiming really, really high, aiming for carbon neutrality, these really difficult targets. And so not long after this, not to be outdone, the United Arab Emirates stepped up and said, well, we can build one of these too. Their project was called Masdar City. This is meant to be, despite what you see around it, it's actually in the desert. It's in the middle of the desert in outside of Abu Dhabi. Again, meant to power all of its own energy use with solar panels plastered on all these roofs. That's why they all look sort of grayish. And this was in 2008. Now, solar technology 10 years ago, almost 10 years ago in 2008, really wasn't as good as it was today. And they found out pretty quickly that they weren't going to actually be able to power the entire city with just the rooftops. So by about 2009, they were already starting to walk back some of their goals. Again, they said this was going to be the most sustainable city in the world. A year later, we're finding out it wasn't true. And so that's when the Sino-Singapore Tianjin Eco-City was just getting started. And they had seen the failure of Dongtan. They'd seen the failure of Masdar, and they said, great, we're not going to try and do that. We're not going to be the best. We're not going to be the best in the world. Instead, we're going to be realistic. And they came up with this, which I apologize the colors aren't rendering as well as they did on my laptop earlier. It's also an image. I didn't really have choice over this. They said, we're going to come up with these key performance indicators, specifically in water, environment, and energy. And if any of you have been to China or know much about cities in China, especially ones around potable water and breathable air, are really important indicators for cities in China. And you'll notice here that some of them 100% green buildings. That's pretty much, it's a very reach target, but then only about 20% renewable energy to power the city overall. So they were trying to say, look, we know that if we aim for everything to be perfect, we're not going to get there. So we're going to try and be realistic. When I visited the project in 2010, this is what it looked like. As I said, it was started in 2009. They came up with those indicator systems, and I got to see the debut of that in a public conference in Tianjin. But all that stood there was this sign. Now, for me, it was a little bit of an interesting journey as to how I got to standing at an eco-city project in China. So I want to take a moment and kind of go through that and of why this particularly piqued my interest. And this project in particular piqued my interest because it wasn't trying to get all of these really high-end targets. We were already talking in this country about doing net zero energy buildings, basically powering your entire house off of the electricity grid. So why weren't they trying to do this in a brand new building? Well, so for me, the way that I ended up getting here, I was here with a bunch of architects and engineers who came to sustainability sort of as an afterthought through their professional work. For me, I kind of started the other way around. I started by getting interested in environmental studies, and I did something called Envirothon in high school, which is basically a science bowl for a bunch of environmental science nerds. I brought this up because I realized like 2 days ago, this was actually the first photo I ever posted on Facebook. This was from my senior year of high school. It's like when Facebook was pretty much brand new. So I started by learning about things like forestry and wildlife and waterways. And that's what I thought I was going to spend my career doing until my senior year of high school, we started talking about climate change. And this got integrated into the competition in 2006, which was my last year doing the contest. And as many of you know by now, we all sort of now grow up with this understanding that all of the industrial activity in human society is driving greenhouse gas emissions up. And the more I got interested in this, I started reading all of the reports on climate change, the more one thing stood out to me, and that was that buildings, and cities especially, have an incredible role to play. In fact, cities occupy less than 2% of Earth's land area, and yet they're responsible for over 75% of natural resource consumption and over 70% of global carbon dioxide production. That's pretty impressive. And it's more impressive when we look at just how many people that covers. Today we have 7 billion people on our planet, and as of 2 years ago, exactly 50% of them, now a little bit more than 50%, live in cities, about 3.5 billion people. That's the first time in world history that half of the population has lived in cities. If we project out to 2050, well, it's going to get a lot more crowded. 10 billion people are going to be on the planet, and 6 billion of them are going to live in cities. So it's imperative that we find solutions. If we know that cities are driving carbon emissions, they're driving resource consumption, and yet we're populating them more and more, we need to find solutions. And I'm going to make this problem a little bit worse before we talk about how to make it better. Most of that growth happens in places like China, India, Africa, South America, where a move to the city means giving up a rural way of life that often hasn't had many of the amenities that urban dwellers have had. We here have a massive electrical grid, so nobody in this country is without electricity. It's a right that has been endowed to us by the federal government. That's not true in Asia. It's not true in South America, in the Middle East, in Africa. So when somebody in China moves into a city, it means that they're going to consume more energy. If you look here, I apologize, the numbers are a little bit difficult to read, but the redder it is, the more energy is used in that country per person. This is not absolute, this is per person. So you see those areas where those cities are going to grow. That's what's driving this energy consumption is movement to cities and affluence. It's the same if we look at water. Again here, going water withdrawal per capita this time, I apologize, my index, this is the higher, but still again, red is higher, blue is lower. And same thing, there's a correlation here between moving to cities and drawing more resource consumption. So this is a little bit of a motivation why, when I was in China in 2010, these projects, these sort of eco-cities were very vogue. There were over 300 of them being planned at that time. And so let's return now to Tianjin and ask a little bit about, well, what happened with this project? Remember, it's not trying to be the best. It's trying to be better. They were trying to set a new standard for low-carbon living. Well, it's now been in operation for about 6 years, and a scholar who splits time between London and Beijing went out and did a ton of survey work. I actually know one of his grad students who's now at Berkeley. And what he found and published last year was that despite all of these targets, the city's consuming or producing 30 to 40% more carbon dioxide per person than London. If you think about London, London's been around since, about 23 BC. And they use more water per person than London. We saw before, China, on average, uses less energy per person, less water per person than England. But this particular city is using more. And what's more, when they project these out, they say, okay, well, let's give them a pass because the development's not finished, right? Give it 4 more years, everything will be built, maybe that'll change. This number actually gets a little bit better. That one, they don't expect to. So the question becomes why? How do we actually do worse when we were trying to do better? And ostensibly, this looks like a great place to live. So let's dig a little bit deeper. And let's ask ourselves, well, what are we actually trying to accomplish when we plan a new city? This blue box in the center is going to represent my city throughout the rest of the talk when we see slides like this. And we have some things that we can change. And all architects, engineers, we think about these sorts of questions. What types of buildings are we going to build? How tall are they? What uses are they? How do we landscape? What materials do we use? Where's our water? Where's our energy coming from? And so these are the things that we can vary when we plan a new city. A lot more things than that. I'm just giving you a simplified look. And what we're actually trying to care about when we talk about an eco-city is, well, what's its impact when it comes to global warming and water stress, air pollution, habitat degradation? There's a field that really helps us understand this called life cycle assessment. And so what we would consider here on the left are called inputs. Over here, those are our endpoint indicators. That's what we actually care about. The real challenge is that I can't necessarily draw a direct line between materials and landscape and global warming. Maybe in some cases I can, but it's really hard. And so we use these key performance indicators, this sort of middle step to get us from what we know we can change to what we can measure to the outcome that we actually care about. And so this was the step that city was trying to incorporate. You'll notice some of the same things on my list here of key performance indicators that they used in theirs. We have things like carbon emissions and renewable percentages, which we can measure. If we're thinking about planning variables, how far is it between buildings? How far might I have to walk? And how many stores or shops have I put near where I'm living? So this is what we can change on the left. This is what we can measure, and ultimately what we're trying to affect. And like I said, if we go back, okay, it seems like they actually have a pretty comprehensive set of indicators, but the problem really comes when we dig one layer deeper into each of these. So for instance, we can already point out maybe 100% of green building, 90% of green trips. Well, what does green actually mean? It's kind of an ambiguous word. Well, they did have a little bit more definition. So in this case, they wanted LEED certification. LEED is the global leader in green building certification, no pun intended. And 90% green trips, they meant walking, biking, or taking public transit. Well, that's great. And we know that this works in principle because everybody's doing it. This was not like they were coming up with a new methodology. LEED, as I already mentioned, has a certification system that's based on exactly that. Here's some indicators, let's meet that. There's a new group out of Portland that does the same thing, eco-districts. Let's look at a bunch of indicators and see if we can do it. Basically, whether it's in policy, we have in California an ordinance called Title 24, which is a checklist. Have I done all these things to meet my energy targets? Or whether it's something that's a voluntary rating system, this is kind of the way that the industry works today. The challenge is when we actually break it down. We might know very, very well what my energy source is and what its carbon emissions are. So for instance, if I have a solar panel, I know, I can calculate how many carbon emissions went into producing that, and I know that if I'm just getting energy from the sun, well, there's no emissions factor. If it's natural gas, I can tell you exactly how many pounds of natural gas per kilowatt hour of electricity I produce. And we know, thanks to really smart folks over here at the Carnegie Global Center and similar institutes, we know how that links to global warming. We may think that we know things about what type of building, how that links to carbon emissions, and then of course that second link is the same. But it actually turns out that as soon as we get to a decision that's not a clear-cut technology, this becomes really muddy. So go down a rabbit hole with me for a second, and let's talk about buildings. I mentioned LEED already. LEED is Leadership in Energy and Environmental Design. It's been around for 15 years, more than 15 years, I believe now, more like 20. And it's a rating system that you've probably seen around campus because we have quite a few LEED buildings, LEED certified buildings. If you meet certain measures, it means that you're supposed to have a better performing building. Well, this group in Oregon, the New Buildings Institute, went through and they grabbed a bunch of LEED certified buildings and said, let's measure how much energy they said they would save versus how much energy they would actually save in operation. They looked at real data from these buildings. Now, keep in mind that when you model these, it's a really complex process. It's a really intense simulation. I now work with a bunch of people who, to build a model of one building, will spend about a week's worth of full-time effort. So that's like 40 hours of time just to build a model using commercial software that's available. That's how complex this gets. And yet we see that we really want to be in the upper half. We want to be saving more than we propose. But a lot of our buildings actually are not. Even in the upper echelons of gold and platinum rated buildings, some of them are even performing worse than the minimum requirement by law for energy. It's really not that simple. Even though we have all these ways that are scientific and driven, it's really not that simple to say how much energy buildings use. Same thing with water, same thing with others. And it gets even muddier if we try to say, okay, if I have a type of building, I can probably calculate how many amenities that are in a quarter-mile radius, and this is something we use for walking, right? It's nice to walk, then we don't have to rely on cars, etc. And again, we can say how much that contributes to global warming, but actually those models don't really exist. Ask Andrew, he's going to spend his PhD doing this for us. It becomes really hard, even if we think we can say, oh look, I know that downtown Palo Alto is right down there, I know that I can walk there. Well, that's great, but do you actually walk there? Do we actually know how people are going to behave? And that becomes the missing link. So the reason this is all so messy and the reason this all gets so hard is that cities are complex, self-organizing systems of systems. We're sitting here in Silicon Valley, we have the power of all these computers surrounding us constantly. Even the most advanced machines we have struggle to represent these types of structures that exist in nature, let alone simulate, optimize, and make decisions for them. I probably need go no further than to show you something that looks like this. And this is a simplistic representation of all of the resource flows and technologies that exist in cities. And I apologize, it's not in English. I didn't have an English translation of it. This was something I picked up in Europe out of my travels. So what I'm trying to show here is that all of this right here, this is really what we control in our decisions, is just that layer, just what we build, where we build it, We don't control anything about the people or the animals that exist in it, but we know that they have impacts. We don't even control oftentimes the way that it interacts with what's around it, whether that's underneath the surface, how we move water or energy or waste to it, if there's pollution, what happens there, or all the natural interactions. This gets really challenging to even understand, let alone make decisions about. And so I want to talk about three things that make this a really, really challenging problem, and I apologize that if you were looking for a solution, I'm going to disappoint you right now. I don't have one. But I want to talk about why this becomes so challenging to deal with. And the first has to do with trade-offs. It may seem obvious that in some cases we have trade-offs that we have to make when designing cities, but a lot of them we don't actually learn about till after the fact. So one good example is if we want healthier buildings. Research from Berkeley has shown us that we need increased ventilation. We need more air flowing through buildings. Guess what? That actually makes us more productive too. But if we don't have wind, that means we have to use more energy. So we're trading off now sort of our internal productivity versus making the planet warmer under today's infrastructure. If we want more open space, that means we have to move around it or move through it. So it's going to take more energy. Smaller buildings. For the last 10 years, we've driven closer and closer to what we call net zero energy buildings. And net zero energy buildings mean that they produce all of the energy within the actual site of the building. So solar panels, batteries, whatever it takes, they will produce it. And we can do this now. We can actually do it cost effectively. But we can't do it for big buildings. So we're going to sprawl if we have to do that. There are other trade-offs here. If we're going to try and recycle water, because here in California we know that's an imperative, well, that also takes more energy than our traditional wastewater systems often. And it even crosses over into the social realm. If we say want to have greater revenue from a city perspective, just look at San Francisco. Record tax rolls, but who can live there? So these are all things that we have to start to think about, and it becomes a challenge because all of these we only start to understand once we ask ourselves what happens when we try to do one of these factors. So we learn through doing, but can we find a way to make these trade-offs more explicit? Now to draw back to the tea and gin example for a moment, I like this picture because it shows explicitly what the trade-off the designers made was. Each of these trade-offs represents a choice. Well, you see this couple standing here pointing at their beautiful city. That was their trade-off. The fact that you could get 30 stories up in the air and you could look out over all of this green space, but look how far that makes the buildings sit apart. It looks walkable because it looks lush, but the distance from here to there, I'm going to just kind of estimate that that's probably the distance between here and maybe the oval. And between here and there, if you look, there's maybe one or two stores. It turns out not to be so walkable anymore. And in fact, that was why, from this study that came out of London, that was why they're using more carbon per capita, because there are a lot more trips that they have to take on these roads outside of the major residential areas. That's where they have to drive to get to different places. And the reason they have to do it is because the trade-off was made to get this greater amount of green space. That was the thing they are most proud of in their marketing materials, is how much green space there is. And for China, it is phenomenal to be this close to a major city and have that level of greenery. But here's your unintended consequence: higher carbon emissions. Now there's another factor that went into this, and that, before I get to there. Right, so I was going to share, this is the one time I will dive a little bit into my own research, and that is that this is exactly what I focused on. This is one of the three problems really that I started to focus on in my work, which is, can we better value these trade-offs? Can we actually start to understand and look in advance at what those trade-offs might be? So all of my work revolved around applying some measure of computational power to looking at different decisions that could be made, building models that represent those, and that using a multi-physics simulation could actually start to examine just the environmental trade-offs. We'll get to social and economic later. This is, high-level wireframe, kind of what it looked like. Looking at energy, we can model demand, we can model supply. I already showed you that, well, this isn't actually as accurate as we'd like it to be, but we'll take that as it is. And then we can try and optimize it. And what we end up getting is plots like this, where each of these represents a new city, a new development. If I were to say that to blow this up, I could show you all the different buildings that go into it. The point I just want to make here is that there are so many options to consider that it's understandable why we can't really understand how these trade-offs impact each other, right? If you were a designer, how could you ever possibly examine each one of these and understand what its impact was? There are a lot of decisions that are made in each of these simulations that could lead to very different consequences, whether this is the baseline of what I was comparing. I found options that had worse carbon emissions, higher carbon emissions. I wanted to get down here, and I found some that were much worse. So you can understand now why, even with some of the best technology, we can't always be correct. And part of that is context. As I said before, the group that designed this city in Tianjin, they were some of the best architects and engineers in Singapore and China. And the reason they did as well as they did, and I think that's actually a really phenomenal project. I'm kind of, bashing it a little bit, but it's actually a really cool place. The reason they did as well as they did relative to Dongtan and Masdar was because they understood the local context. Dongtan and Masdar were done by architects who flew in from Europe and Germany, spent a day or two there, and then flew back and went and drew on some paper at home. Dongtan didn't represent how people live in China. Masdar didn't really represent how people lived in the UAE. They didn't represent the local culture and the local ecology. At least Tianjin got that right. But the context matters in the systems that surround the city as well. So, for instance, how close you are to other surrounding points of interest means that you may have to travel farther. One of the things that we're seeing now in America is that as we get to higher levels of renewable energy penetration, you can no longer just rely on the grid to always be there. The way renewables work in this country today is if I put solar panels on my roof and I'm not using the building, I sell it back. Somebody else uses it. But if everybody's doing that, I got a problem. And we're actually starting to see that. There are parts of the country that are now starting to have instability on the electricity grid. And that's because context matters. It can't absorb the energy. We have things about land use impacts. Dongtan was another example of context-driven challenges where they were taking a functional wetland and converting it to a city. There were going to be huge problems with siltation downriver that they didn't even consider because they would have had to design on that river plain. So context matters. And let's go back to Tianjin one more time. Apologize. My slides, I threw a couple in here at the last minute. This was one of them. So context really matters. And this is showing energy use in the United States. In my red box here, these are the decisions we can control at the city level. So if we're talking about carbon emissions in a city, well, these are all of our sources of energy here. If we can only control that part, this is 90% of our energy-driven carbon emissions and the impact that it has. How much coal am I pulling? How much natural gas? And yes, maybe we can offset some of that, but this is a big deal. And so in Dongtan, the biggest context issue was, Tianjin, the red box up there got cut off, unfortunately. That's where the city is. The new eco-city is. This is the center of town. That's about a 45-minute journey on the light rail, and then you have to take a bus. Oh, there's great public transit once you get in there. Doesn't help if I need to go to town. So again, context matters. Also, to do that, I should point out, this is all industrial development. It's not a very pretty ride to get out there, so it's kind of disincentivizing for people to actually move out there. But anyway, my point is that understanding all of these decisions, and I was actually in a meeting today talking about a new city development, and I was starting to see some of these same issues come up, that how do you get to the surrounding areas was just being completely forgotten because the investment was so focused on what happens in the city to make it sustainable. If we come back to the indicators, the other important point about context is that not every indicator is going to translate perfectly to a different city because of that. So for instance, in China, we could get greater than 20% renewable energy use because there's a huge baseload of energy that we could be selling to. To set this kind of target in certain parts of, say, Costa Rica or the United States would be a little bit more challenging given the way the electricity grid works currently. Similarly, if you said, we're going to have 100% potable tap water anywhere, well, maybe a couple of unfortunate recent cases, you would be looked at like, well, why is that even on your list? So we take it as a given. So context really matters. We don't always have the same indicators in every place, and yet when we look at these large projects and when we try to benchmark internationally, this is what we end up with. We end up with the same list, and we always will fall short. And then the final thing, and perhaps the most important, is decisions. Trade-offs, context, all go into decision making. And if we're talking about a new city, hundreds, thousands, sometimes even millions of people have a voice. They don't get a voice at the table, but we have to recognize that they are stakeholders. There are hundreds or thousands of decisions that go into every individual planning exercise. And each person, each stakeholder, whether that's the architect, the engineer, the resident, they think their issue matters the most, their priority is the most important. And there are, a lot of valid concerns that as a result we just cannot recognize. So for instance, if somebody wants a dog park in their neighborhood, that's probably not going to make the top 10 of the Planning Commission's issues in San Francisco or in Oakland or even in Palo Alto. But to that person, it's the most important thing in the city. That's supposed to say many of our rules are not universal, which I sort of just hit on. And this is an important point to make, that because of the complexity, because of the trade-offs, and because of the context, we like to boil things down to simple indicators or simple rules. Unfortunately, it's not that simple. If that's the one message you take away from that, it's that anytime you see a policy, anytime you see a plan, San Francisco, 6 months ago, passed a policy that 15% of all new roofs in the city have to be solar. So 15% of your house roof has to be solar. Maybe that's not the best policy. Maybe it is. But it's not a universal, and it's not necessarily just as simple as that. And the main reason it's not so simple is because of us, because of all of the people in this room. We are still really terrible at understanding behavior. We are really terrible at understanding how each of us is going to respond to different incentives. And what I love about this series is that in 2 weeks you're going to hear from one of my good friends, Greg Sparkman, who is a psychologist and who studies exactly this, how you get people to respond to energy efficiency, how do you instigate that behavior. He's done some wonderful research. What this also means is that we have a whole set of decisions that I haven't even talked about when we think about cities. And this is where ultimately those trade-offs get ranked. I've talked mostly about environment. All of my research was on environment. But we don't just care about energy. We care about poverty. We care about health. We care about economy. We care about the climate ultimately. But it's one of many factors. And you know what? That one often takes a backseat to everything else when we talk about planning cities. We need to plan places people want to live. And if you think it's hard to plan a city and model it from an energy perspective, when I know the first law, second law of thermodynamics, I know heat transfer, mass transfer, we've known these things for 100 years. It gets even harder when we try to balance priorities. The reason this plot looks the way it does is because there are so many decisions that affect how people live. And that's just a big black box. We, to this day, cannot draw a line between what type of building and how livable that makes the city. Everybody will have a different opinion. If I could show you 10 different landscapes, and I'll bet I'll get 10 different opinions on how much you'd like to go visit it. We have no idea how to draw the lines through this box. We at least have some idea on the energy and environment side. When it comes to livability, no. Once again, 5 years, Andrew, it's your PhD. So I want to end with one example that really hits that last point, or the last two: context, decisions, and livability. How many of you are familiar with this book, Cradle to Cradle? A couple hands. I suggest reading it. It's a wonderful book. It's about life cycle assessment, and it's done by two guys, William McDonough and Michael Braungart. Bill McDonough is a very well-respected, very well-known architect. Michael Braungart's a very well-respected chemist in Germany. But even Bill McDonough, who understands this stuff backwards and forwards, has the best of intentions, even he doesn't always get it right. And I'm glad he'll never see this presentation, because I'm going to talk about probably one of his firm's biggest failures, and that's the eco-city of Huangbaiyu. So this is another one that was planned in China around 2008, 2009, in a more rural area. This was the ultimate plan. It's about 500 houses, a nice little lake, a nice little downtown area, but it was meant to be a rural town. I visited that project as well in 2010, and this is what it looked like. This was all that was built, and this is all that will ever be built of it. 47 houses, of which exactly one was being lived in. The reason? This might look great to us. This might look great to us. I grew up in the suburbs of LA. This looks like home. It's not home in rural China. This isn't livable. The farmers in this village, even if they were transitioning away from farming, still had a number of household animals, still were used to a large amount of space. And to them, it didn't matter. This rule of thumb that everything that's a quarter mile or less is walkable, that doesn't apply in this part of China. They were used to walking 2 miles. In fact, they enjoyed it. It was a chance to get out and to see people. And if you don't believe me, there was an anthropologist named Shannon May who spent 2 years in this village and did a lot of research. And all of her work points to the same thing. This was just not what the people wanted, but they never got asked. So this was another image of it. This was meant to be one of the town centers, completely abandoned. This is what it looks like inside. You can see everything at this point was just decaying and overgrown. And if you go on Bill McDonough's website, you won't even see mention of this project anymore. And you can start to understand why. So anyway, I think I've gone a little bit more than 25 minutes. I promised you I would. But that's all I wanted to say. And like I said, I hope it's not too unsatisfying that I don't have good answers. It's a messy problem. And even the best of the best today, if you sit and listen to them, it'll sound good. But really ask yourself how you get to understanding more deeply what the true issues are. So we can have a discussion. We can have, I mean, for those of you enrolled, we have 10 minutes till you can leave. For everybody else, I can stay a little longer than that, but we can have a discussion. I'm happy to answer questions, whatever you guys would like. Yeah?
So I know that like currently Stanford and like Santa Clara County is like rewriting the general use permit for like building codes, and like they're considering like this is gonna set like regulations I think for like the next 20 years, and like we talked about this at one of the sustainability clubs.
Yeah.
So we were like looking to get involved in for one of the project groups, like trying to figure out what measures in terms of green building design should be modified or included in the GUP. So I was wondering what your thoughts were on it, if you're familiar with it.
So I'm not familiar. I know that the general plan is being reviewed. I'm not familiar with the specifics of it. This is one of those cases where it's really site by site and context by context. Stanford's a really, really unique environment. I'm sure all you guys know we just built a new central plant. It's actually hugely efficient and saves us a lot of energy and money relative to our old system. And because of that, it changes really drastically what you would actually do in the buildings. A lot of what we would design today, that's some of the sort of best design, is not 100% compatible with the system that you guys just built. We just built. I guess I'm still a student here. So I'm not giving you specifics, and I'm intentionally not giving you specifics, so I don't want to be on the hook for anything here. But in general, I don't know what's written in there now, but in general, I mean, Stanford has a lot of opportunities, or new buildings in this area, to reduce energy consumption through a lot of sensor measures. And so what I'm actually most excited about is technologies that provide more visibility into the buildings and that allow you to better monitor, measure, and individually control different spaces. And Stanford's done this in the new Science and Engineering quad buildings, the new Graduate School of Business, but even since those were built now 6 years ago, the technology's moved a lot. And so that's someplace that I see a lot of promise. The other thing that I really would love to see in that is something that is another idea being piloted out of Oregon and Boulder, Colorado, and Seattle, which is called a performance-based code. And so building codes today, as I said, they're really checklists. It's basically like, do you do this? Yes. Okay, great. Here's your permit. These performance-based codes actually ask you to set a target, and they may say that your target has to be 15% better or something like that than the average building. And then you have to prove it. Month in and month out, you have to prove it. And you have to prove it both through modeling and then through measuring your building. Believe it or not, we don't do that. One of the biggest problems here is there's no feedback loop between what we've designed and how it performs. So I demurred on giving you any specific building technologies, but if there were one thing I would say, a performance-based code is probably the way to go because it encourages innovation and it encourages actually checking how the building's doing.
Cool, thank you. Yeah, that was really helpful.
Good. Yeah.
So how do you feel about, so like Google, for example, it's sticking some of its like moonshot companies on like using artificial intelligence to make buildings more efficient. How do you, what's your take on that?
I love it. I absolutely love it. I think there's a huge power in big data and computational power. Like I said, it's a really messy problem, and AI and machine learning is the only way we're going to start to crack it. Me sitting here and building deterministic models is not the answer, and I realize that. So that's right. I wrote myself out of a job in my PhD. No, I think it's really great, and one of the biggest things that I was excited about was their Alphabet Sidewalk initiative, which started in New York about a year ago now. I would caution that the one caveat with machine learning that always exists is you can only glean so much from the data, and it's easy often to confuse causation with correlation. And buildings being as complex as they are, it's going to be wonderful for detecting inefficiencies. There might be a level where you will always still rely to some measure on the people who are operating and know that building best to actually determine. So pulling general rules of thumb out of it, again, may be the grayer area. But the predictive analytics and the understanding my building, I would love to see that on every project. I think it would be 10% or more energy savings, just rough. Yeah.
So what do you think about all the projects you talked to us were about planned cities that didn't exist before? So what do you think about like modifying existing urban spaces and making them more efficient rather than like, I mean, because just building a city in itself takes a lot of like
political will, land.
Yeah, like it takes a lot of
money.
resources, and you're just moving like tons of parts of the earth to other parts of the earth. So
Yeah.
What do you think about like using existing spaces?
It's a much harder problem. I focused on planned cities because they're hard enough, and it's actually, I spent a year studying them before I came to Stanford. That was where I went to China and all these other cases. Existing cities are really hard because the context is already set. You can define more of the context in a planned city. That said, I am wholeheartedly a believer that we should not just be going out and building new cities, because one of the biggest gaps in our understanding of climate change is land use. Whenever you take a stretch of virgin land and convert it to a new city, you are uprooting whatever was there. There's decay, there's release of otherwise stored emissions. And the estimates on what fraction that is of our overall greenhouse gas impact are the most uncertain of any of our measurements of carbon. So even if that were the only reason, I would say that's reason enough to focus on existing cities wherever possible. The other reason is that existing cities already have communities within them. And the one downside that we've seen with the way existing cities have been handled, especially in this country and in Europe in the last 25 to 30 years, is that the value of existing communities is not recognized and celebrated. It's really challenging because to do any sort of major renovation with a population in place it probably doubles the cost of a project. Doesn't mean it's not worth doing. It means you have to be careful about how you do it and how you plan it. So from an emissions perspective, existing cities are definitely the way to go. You should take advantage of every development opportunity you have within a city and try and push the envelope. There are things we can do at a systems level to make them more efficient, but I think where we really still don't have good understanding is on that social level. There was a piece in the Atlantic, I think 5 years ago, about Chicago and informal community networks that had arisen in 2 different neighborhoods of Chicago and how they really helped health outcomes during a heat wave. That those that had stronger informal networks, fewer people, elderly and young people, passed away as a result of the heat wave. And not enough of that is known and recognized. And so, again, I don't know the solution, but it's also a big issue right now in the Bay Area, and something that, if you're interested in existing cities, it is a sustainability facet that we don't talk about enough. We often think sustainability is just technology, just green, and just environmentalism, and we really need to think about what makes people want to live there too. I don't know if that answers your question.
Yeah, it does
Okay.
pretty well.
Good, yeah. No, outside of China and places like India and Middle East, this is not going to happen. Brand new cities, not going to happen. New areas of cities, absolutely. Yeah.
So this is kind of different, but like turbines for producing energy in the ocean. We don't really do it much now, but like, I don't know if you've studied it at all, but is there a downside to those? Like, it sounds like there's gotta be, but
I'm sure there is. I don't know if the downsides. I would imagine there might be some wildlife impacts, just as there are with airborne turbines. There's a positive impact in that they actually have been shown to reduce storm surge. And Chris Field here, who's I believe it's Chris Field's work, has shown some of that to a certain extent. So I don't know of any downsides. They're really expensive. Really expensive because you got to drop them all the way to the bottom of the ocean channel. But I don't know. Check out the Hudson River has some, so you can look up that project and see if they've seen any unintended consequences. That's a good question. Yeah.
So in class, when we had our discussion the other day, we talked about the example of say if you get a Prius, you think that since you have a more energy efficient product, then you wind up using more energy because you just decide, oh, I can use it more. Do you think this is part of the problem with if people were to live in green cities, they would think that their behavior is more sustainable, but then they're actually consuming more because they think they're more efficient?
I love that you picked a Prius, first of all. And it's a great question. I would encourage you to ask Greg that question again in 2 weeks. I think that, yes, that has been shown that there's a rebound effect. It's also been shown not to be as profound in recent studies as people originally thought. But the reason I'm happy you picked a Prius is because let's take it one step further and say a Tesla. So you bought a Tesla, and you didn't put solar panels on your roof because SolarCity and Tesla haven't quite merged yet. If you bought it in California, you're doing the environment a favor. If you bought it in Pennsylvania, you're doing the environment a disservice because of context. Here in California, especially in PG&E, which is our local utility, Stanford buys its own. If you're in Stanford, you're doing really good because we're buying 100% renewable energy, or will be soon. If you're in PG&E, most of your electricity is hydropower. So it's also clean, pretty clean. If you're in Pittsburgh, it's coal. And it turns out that driving a mile in an electric car powered by coal is about 2.5 times worse than driving a mile in a car powered by gasoline. unintended consequences. If there are no other questions, I would actually kind of be curious from all of you, what you think the most important things to consider in planning are, because this is actually really interesting and important to me. What are the things that you guys care about when you're walking around campus or your hometowns or wherever? What should people like me try to be designing for that'll make you want to live in a place?
Being sure that it's not going to be underwater in 30 years.
All right. I didn't even talk about resilience. Climate change, sea level rise. Good. Other thoughts?
I guess one thing that's important for me is like maintaining the integrity of like existing ecosystems, because I feel like a lot of green spaces, they make it look green, but it's actually exotic vegetation that has a very low ecological value to wildlife or can be invasive, and I feel like that's sometimes overlooked.
No, that's awesome. And I didn't even list that up here once, but that's a really valuable point that it can do more harm than good sometimes overall. Yeah. Yeah.
Do you mean like accessibility, like how close things are, but also what things there are, like what kind of shops are there, how to look single in, what kind of beauties and that kind of stuff?
Yeah, it's a great point. I saw Andrew smile, or I smiled at Andrew because we've talked a lot about this, and there are some metrics out there. One of the things I said we don't really understand is livability. There's a metric that tries to measure that, but they prescribe like you need a bank and a church and a school and a this and a that. Is that really what you care about? You got a school. It's got a bank, I know that. Anyway, it's a really good point. And here's where a place that I think there's a really good potential is, again, going back to the AI and data collection question too. We can collect much more directly where people go and what they use. Everybody's got a computer in their pocket that's got GPS, and whether you like it or not, that data is being collected. So why not put it to good use and understand very individually what you want or what the Stanford population wants relative to downtown Palo Alto, relative to East Palo Alto. I think there are better ways we can put that to use in planning. We just don't do it yet. Any other thoughts on what makes a good city?
I have a question.
Great.
So we're talking about accessibility, like driving to get places versus like biking or walking, etc. One thing that I come in contact with now living on a college campus is shipping. So like, do you guys know if it's more sustainable to have the products you want shipped to you, or is it more sustainable to like go and walk there, bike there, drive there?
This is a phenomenal question. So the short answer is no. I don't know. And the longer answer is to the extent that we do know, it really depends on how it's shipped, and in particular how it gets kind of from the warehouse to you is the last link. Ships, trains, pretty efficient in moving them there, and they moved them there whether it was you went and picked it up at Target or whether you ordered off of Amazon. The last mile, it's really challenging. There's some early studies, I mean like recent early stage, that show that to some degree having these consolidated drivers is better, but that's under the assumption that everybody's driving their car to get to Target anyway. So 100 cars going to Target and then going home, and then 100 cars going to the grocery store and then going home, versus one vehicle that's making those deliveries and can optimize its driving route, which UPS has a phenomenal optimization algorithm for their truck deliveries. I don't know about On Track, which I know Amazon uses out here mostly. In that case, yes, but again, it depends on how you get there. Say that each of you, because you live on campus, don't have a car and we're going to bike downtown instead of ordering on Amazon. That's probably the better option. I'm not really sure. I guess it's the better option, but we could go into the details of how much more you eat at dinner that night to make up for the calories you burn and what are the land use. Anyway, it's a hard question, but I don't think we'll know anytime soon.